Hey guys, all right, we're gonna kind of continue where we left off on Wednesday, looking at some circuits and continue with some just basic general knowledge of circuitry related to automotive. Just to review, we're breaking down our circuits into three areas, all right? A lot of threes when it comes to circuits. So we have voltage, we have current, we have resistance. Those are parts of electronics and circuitry. But when we're troubleshooting the circuitry, we're going to refer to three different areas of our circuit path. All right. We're going to have the power, which is from our battery going through any fuses, switches, anything that's not consuming current. All right. It's just passing through stuff. And there are safety features there like the fuse. There's control like a switch or other aspects that we might come across. So this would be the power supply of our circuit, all right? Then we're gonna get to, in this case, this is our simple circuit we're working on now. In this case, our bulbs, all right? Our bulbs are gonna be our load, all right? So we have power, we have load, all right? That's gonna be this section of our circuit right here, all right? And then the final is our ground path. All right, and those three areas, we're going to treat them differently, all right? Because we're expecting different things to happen on our power side. We're expecting different things to happen on our load side, and we're expecting different things to happen on our ground path. And so we can identify what one of those three is the fault in our circuit. All right, so let me... So let's say, for example, again, we're just looking to troubleshoot those three areas. So let's say, for example, my fuse blew. All right. Why would my fuse blow? This right here popped. Why would my fuse blow? Well, if you look at this, I have a 5 amp fuse. So anytime more than 5 amps was going through my circuit, that fuse would pop. All right, that's a safety thing. These components aren't prepared to take more than 5 amps. All right, and so if they're getting more than 5 amps, that fuse pops so these don't blow up. All right, fuses are very cheap. So what would we do then? What's the first thing I would do if my fuse blew on my circuit? All right, and there's more than one right answer for this. Probably the first thing I would do is replace the fuse. All right, it could have just got worn out. If you haven't replaced any fuses or anything like that, it's not very likely. There's probably something going on, but still, fuses are like 10 cents. All right, we could replace that fuse at a low cost and we could still find out some more information. All right, so I'll go ahead and I'll replace the fuse. All right, I replace the fuse, I turn on my car, that fuse pops again. Now, this tells me something right now. This switch is open. There's no current going through this circuit. So in its normal state right now, all right, if that fuse is getting amperage at all, it's because I have a short to ground somewhere, all right? Somewhere between this point and this point, electricity is getting to ground. It's getting back to this battery, all right? This symbol right here just references ground. It allows us to, I don't have to draw that wire in every single time because on a complex circuit diagram, I would have 25 wires going here and it's just impossible to read, all right? So if you see that symbol, it's the equivalent of having a wire drawn to there. So right off the bat, I replaced my fuse, it immediately popped. It shouldn't have done that because this switch was open, all right? So my first thing to look, I probably have a short to ground right in here. Now, let's say I replace that fuse and it doesn't pop. But then I turn on my switch and then the fuse pops. I learn more information, all right? I know that somewhere between here and here, I have a short to ground. Again, the whole purpose of all this is identifying where the problem is, all right? Or what area of the circuit the problem is, and then we can tackle that problem. All right, so we're just trying different things, and what are we trying to? What's happening? What's causing this? And then we can keep narrowing down that search until we fully identify what's actually happening. So that's a pretty simple example. So if I have a fuse out, again, I'm just learning a few things from that. All right. anytime when it comes to circuits, all right, you got to ask yourself 3 questions. You got to ask yourself 3 questions when we're diagnosing a problem. See, I told you, always threes. Threes, circuit, volts, ohms, resistance, threes, ground path, load, and power, threes. 3 questions to ask yourself, all right? Before you start testing anything, what do you expect? Like, what's the purpose of testing something if you don't even know what's going to happen? All right? You take a voltmeter, all right? This guy will talk about this in a minute. You take a voltmeter, and I'm testing things, and I get a number here, but I have no idea what I even expect anyway. You have no relevance to that anyway. So that's just a waste of all of our time. You need to have an expectation. Next thing, what did you measure? Now, we're primarily going to be measuring voltage. It's the easiest thing to measure, all right? You can measure amps with this. You can measure ohms with this, all right? When you measure amps, you got to move this lead over these other things. So there's an extra step involved. Volts, simple, 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 all right? So we're primarily measuring voltage. So if I have my lead set out here, and I'm here, and I'm touching right here, what am I expecting to be right there? If you don't know the answer to that question, don't even do the measurement. All right? I know right here I'm expecting 12 volts. I'm expecting 12 volts there. I'm expecting 12 volts there. Right now, when I touch right here, what am I expecting right there? That switch is open. I'm expecting 0 volts. All right? If I have 12 volts right there and the switch is open, I have a problem. I got a broken switch. All right? So, again, what are you expecting? All right? And then last thing, what does it mean? What does it mean? Again, in this situation, if I have 12 volts right there, right now, with an open switch, that means that that switch is probably bad. That's the first thing I'm going to look for because that switch is probably faulty. All right? Now, keep dropping my pen. Let's look at the 4 types of faults in a circuit. All right, 4 types of faults, because that's going to help us with this what does it mean thing. If we can identify what type of fault we're having, there's a different process to finding the solution to that, right? Okay. First fault, probably the most common fault, all right? We have an open circuit. Open circuit means we have a missing or broken wire, all right? There's nothing there. That wire broke right there. I cannot get voltage to the other side of that, all right? This is probably the most common fault that you'll see, all right? A wire came loose from a connection, fell off, all right? Boom, we have an open circuit. So, missing or broken wire. Our next type of fault, high resistance. High resistance. Again, I'm not going to get marred down in the math on this, but Ohm's law says voltage equals amps times resistance. Voltage, amps, resistance. All right? For most of the stuff here, we're dealing with 12 volts. All right. Well, let's say I'll do 36 ohms of resistance because that's going to be a number I could deal with in my head. All right. If I had 36 ohms of resistance, I know that I is going to be 0.333. Well, a third of an amp may not even turn on a light bulb. All right. It may, some LEDs and stuff on your dash, it will, but a headlight, it may not even turn on that light bulb. So my resistance is too high. Now, what causes this? Typically, there's many reasons, but typically it's either corrosion or poor contacts. All right? And it could be that those go hand in hand oftentimes. All right, so when you have wire connections, which there are a ton of in your car, typically through a wiring harness, all right, if something gets wet in there or whatever, you get corrosion in there, and corrosion's not as conductive as copper to copper, and so therefore you don't have a good of a contact. It shows up on the meter as high resistance, and then we usually just clean that contact or replace that contact. All right, so we have open, we have high resistance. All right, the next one would be short to voltage. Short to voltage. Now, I don't see this one as much. Usually when it's short to voltage, things aren't acting the way you want them to do, all right? Like if you turn on one switch and another thing turns on that shouldn't be on that switch, all right? That's the example of short to voltage. So we know from our battery or from our alternator, we're gonna have a wire harness and it's gonna go everywhere in the car, right? So we have a bunch of stuff right there. Well, let's say for some reason, let's say that I'm coming off of here, separate circuit, all right? I have my fuse. All right, that's a horrible fuse. Let me see if I can improve that. All right, I have my fuse, I have my switch, and I have my blower motor for my car. All right, I have my AC blower motor. And for whatever reason, these two wires were ran in the same piece of conduit along my rail to either the headlights or the blower motor for the AC. All right, so they ran together and then they separated later in the circuit. All right, they weren't touching, they were just using the same, they were just all zip tied to the same rail. All right, well, those two wires can rub against each other and actually make a connection. So accidentally, these connected. All right, well, what would happen here? I would go to turn on my AC, I'd close that switch, all right, and then my headlights would turn on. My AC would also turn on, and my headlights would turn on. All right, but I don't want that. All right, that's a problem in my circuit, and so that's short to voltage. Things are getting turned on when you don't intend them to get turned on, which is a problem. All right, we don't want that. All right, and then the last one is that we've kind of talked about is short to ground. So I'll get rid of this stuff. Get rid of this stuff. Short to ground, you've seen it before. You know, if this circuit got to ground before it went to this load, all right, this is a more common one that happens. All right, so this wire was rubbing up against the frame, and the frame, just because of vibration, the frame rubbed off the plastic or insulation coating on that wire, and the bare wire touched the frame right here, all right? And the frame goes all the way back to the battery or to the alternator, so then it's a short to ground, all right? And so if we had this fuse would probably pop, and that would be the most common. So again, we're looking at three different parts of the circuit. We have the power side, we have the load, we have the ground path, all right? To troubleshoot each of those three, we're gonna take a different approach. All right, or we have different expectations when we're measuring things, all right? Because on the power side, we're expecting voltage to be pretty constant going all the way through. On the load side, we're expecting to see voltage drops all the way through, all right? And on the ground side, we just have to have a continuous path to ground. So those are three different perspectives that we're looking at there. Now, and then our four types of faults. So pretty common, open or broken wire. You'll see this a lot. High resistance, again, very common because of poor connections and stuff. Cars are on the road for 20 years. Things get loose, things come out, things get corroded, all right? Short to voltage, you'll see sometimes. In my experience, I don't see it as much. And then short to ground, I see a lot as well. When a wire just comes loose or breaks, or and then by it breaking, it then touches usually the frame, and then it shoots it back to the battery, and you got to short that way. All right, our four faults. And everything else seems to be in threes. Let me know if you guys have any questions. Thank you very much.